So it looks like we got a pretty good turnout here. Um, I think everybody knows each other at this point. I don't know if we need to do introductions. Let's see. Yeah, David, you know everyone, right? I think you've been to a couple of these now.
I think everyone but Andre.
Ah, well, Andre, meet David. David, Andre. There we go. Okay,
What?
well, I think now we all know each other at this point. Um, so yeah, so I've linked to the agenda here. So basically, I think we've had a lot of progress in the last month. So I think we have some exciting things to talk about for sure. Um, maybe I could just review briefly what we've done. I guess we had a hackathon about 3 weeks ago, which was kind of fun. So a few of us attended that and got some stuff work done there. I think it was a valuable exercise. I'd be willing to do it again at some point in the future. Perhaps we should think of scheduling something in July for that if people are interested. Um, and the other big thing that I think we could say we finished in the last month is the pre-features. So that's of course thanks to Jim and also Avelino for coming up with that shoelace formula for the areas there, which saved our skins. So at this point, we can go right from the contour to all the pre-features and then onwards to features. Um, so big progress there for sure. So I'd be interested to have a bigger conversation with Kezi and the rest of the guys at the Brown Lab there about how we now link the computer vision step and what the output of that is to our work now, because I think we're at the point where we can actually link them up. In fact, um, maybe that's something that we can talk to briefly right now. Um, Before we get into individual updates. So here I talk about progress on in the minimum viable product here. So this is the idea of just chaining together the pipeline, however minimally, from video all the way down to some kind of fitness function for OpenWorm. So let's see. So if we look at video to features, this was sort of my attempt at doing this. Um, so I have on line 19 here. Here, let me put this up on. Let me share my screen. So let's see here. Can everyone see this? Is this too small? Let me see if I can make it bigger. How's that? I'm getting some nodding. Okay. So so basically, we import movement validation, and then we obtain the ventral contour, the dorsal contour, and some video information like the resolution and the frame rate um, from what I'm calling Kezi CV algorithm. And we've just passed it test.avi, so one video. And from this contour information, then um, we should be able to create a basic worm just from this factory method here. And then from this basic worm, we can go on and do the rest of the pipeline here. That is, calculate the normalized worm, and then calculate the features. And then eventually here, lower down here, I'm actually working on calculating the histograms and then visualizing them here. And eventually we'll want to have a fitness function right after this. But I'm interested to hear from, I guess, the Kezi and everyone else there, how close you guys are to having this method actually be able to produce the output that I'm sort of expecting here, or if I have something totally off and wrong about this. So maybe is it worth reaching out right now? Like, I don't know, Kezi and Avelino, do you have something to sort of talk about this for this? Oh, I don't think I hear you guys. I see. Nope, not hearing. Avelino, are you trying to say something? Some microphone issues there, I guess. Everyone can hear me, right?
Yeah.
Okay, well, that's good.
You're going to want to hit settings. All right, there you go. You're going to want to hit the settings thing at the top of the screen.
Can you guys hear me?
Yes.
Okay, yeah, let's just use this. You can leave the door open. Leave the door. Oh, okay, fine. Yeah. Oh, well, let me turn off my computer.
Oh, I see you guys back there. Yeah, okay.
Okay. Yeah, it's not like we're far away. Yeah. I just don't like to share.
Right.
Yeah, it's a big book. No, I mean, like, the thing is, like, right now the output I'm generating, I mean, I have this multi-worm tracker, right? And the output I'm generating is a big HDF file with all the worms inside there. It's kind of like a big, just a big file, and the skeletonization is kind of like included in the part. Like I'm using the segworm algorithm that is supposed to be kind of like more robust, like I show you more or less. So, I mean, basically, those three outputs I can generate, but it's not. It will not be per. I mean, I can do it per worm, but it requires to call us some extra functions. There is. I mean, if you want that to be kind of like the basic structure, I can just link both of them. But then what I'm doing so far is because I'm already using the features, extracting the features. But what I'm doing is I have like this big file with the skeletons. Then I create kind of like an artificial. I forgot. I don't use basic worms. I use a normalized worm because that's my output. Because it's easier to store it instead of having like worms of variable pixels. And then I link it to the features, and then I come back from the features. I take it back to a matrix that kind of help me to organize all the worms inside a single plate.
So when you say features, what are you calculating all the original Schaefer features, like the single worm features, like length and amplitude and turning, crawling bends, that sort of thing, or are you meaning something else by that?
Of the worm to do that. I'm taking everything that you output in worm features.
Oh, I see. So you're talking about using the movement validation code itself. Okay, that's good. Okay.
I'm using your features. Like, yeah, no. That's a lot of work. The only thing I did is what I was commenting, that instead of having histograms, I subdivide in a lot of like the original paper has like these 702 features, I think so. I do the subdivisions and calculate the means instead of having the histograms, because we were discussing with Andre, like the histograms itself are not very. I mean, yeah, they're.
I think we're getting away a little bit from the issue here, though. I think this is more downstream analysis. I guess the question at this point is if we are ready to plug in code to that gap, if I understand.
Yeah, it's true that you guys have a more like what's complicating this is that the original Schaefer Lab code was obviously a single worm tracker. It assumed one worm, whereas now obviously there's multiple worms here. So my original understanding of this was that there was some kind of mask that was being applied at the very initial stage, which was separating the single worms out, and then hopefully, in my mind, the idea was that then we would just be able to deal with one worm at a time and drive each of those worms through this pipeline, through this single worm pipeline. But it sounds like, Evelyn, you're trying to sort of deal with them all, like the skeletons of every one of these worms, multiple worms tracked by one video at the same time in some sense? Or is there still a way to sort of hive them off and then send them out?
I could do that. It's not too complicated. I mean, my main reason to do that is because sometimes the worm identities get messed up, and I kind of like separate worms, even if they are not separate worms. Later on, and I'm working on that. I want to find a way to identify them again, and having them as separate worms in different structures complicates things a bit. That's my only rationale to do that. Like, obviously, I can come back, and then to saving to like I don't know. It's just maybe it's the way I'm thinking. It's just like with tables. I think it's kind of easier. It's kind of more with the paradigm of SQL rather than having like a lot of structures of worms. I mean, or like the Sheffer Lab organize everything in structures, but I mean, I wanted to go more kind of like in a relational database.
Yeah, that's great. Yeah, for sure. A relational way of organizing it probably makes a lot of sense. Okay, so what can we say about this? Okay, so maybe this is something we can take offline and talk about some more. It sounds like we sort of get a sense of things here. Okay.
Can I add some comments on this?
Yeah, sorry, Jim. Yeah.
So I think the big thing that I'm concerned about is it sounds like you guys have a lot to offer, and I would like it if we can be a resource for you guys and make your jobs easier. And at the same time, I would hope that it's not too much effort to set things up on your end, so you don't sort of take things and run and say, well, it's not exactly how we wanted it. We're gonna take our ball and sort of play on our own. And so my hope is that going forward, we can just sort of look for ways of maybe writing these interface methods that we had talked about a little bit via various issues in the chat rooms, where we can say, oh, this isn't exactly how we wanted it, but if we had this method that was in place, then it conforms to our needs, and we're able to use it, and presumably that helps other people as well. So what I would like to see going forward are ways in which you say, oh, this isn't exactly what we want. How can we get it to where we want? And then we come together and say, these are the steps we need. This is the method that I need in place. These are the constructors. These are the objects that'll help us out, and then presumably help other people out as well. That's what I'd like to see.
I think at this point, and I mean, after I know a little bit more how is the structure of the group in general, because I just start to see the repositories and things. I think it's very important that I document well what I'm done and my outputs. I was telling to Andrew to dedicate the next week to do that, because it's I'm using slightly different formats, and then it just becomes a patchwork for everything. And
that's understandable. I think don't hesitate to say, here's what I have. Can you guys help me take it a little bit further? Or throw it out there to the group. Don't necessarily worry if it's perfect or not. We can help you with it. So I'm really excited about what I think. I think you guys have a ton to offer, and so I'm excited to join in and help you guys.
Yeah, my perspective is definitely. I mean, I agree entirely. Being as integrated as possible is what I would like to achieve. So to minimize talking back and forth between two parallel systems with interfaces and really have things as integrated as possible, I think is excellent. And so, we're happy to be flexible to fit things. I mean, whatever ends up making the most sense, data-wise, engineering-wise. We can also be flexible. I'm much happier to work together.
I think especially we've already seen the fruits of this collaboration. I can't tell you how exciting it was to run that validate features routine the other day. Once we got Avelino's code in there for eccentricity, man, that was amazing. Like, it used to run in 360 seconds or something, and now it runs in 7 seconds. Like, it's crazy. So that was awesome. That was way too cool. And hopefully we can get more payoffs like that in the future.
Yeah, believe me, for me was to like, oh, everything is done. I have to go back to the code.
I know, it's like it felt like a mistake. Like, what is there something wrong here? No. So that was great. Here's a very general question. So, are we thinking that the computer vision algorithm is going to end up being? Is it going to stay in MATLAB? Are we going to, or do you guys envision being able to work in Python and write that? For example, like now that we're using OpenCV and we have it there, maybe it's possible we can leverage that to to use in some sense. What are your thoughts on that, Kezi and Evelina?
Like, well, all my algorithms are in Python. I mean, like,
Beautiful.
I have a worm tracker, like, gets the skeleton and everything in Python.
Okay.
So it's yeah, the thing in this MATLAB is.
I think most of my algorithms are in MATLAB, and I'm happy to convert it to like Python or C++ in the future. But initially, I use MATLAB because the Shepherd's code are written in MATLAB, and there are some many functions I can use directly, so it will save some time. And once we tested that our algorithm works by using MATLAB, then it's convenient for us to convert the algorithm entirely from MATLAB to some other language.
Great. Okay. Just so we're clear on that, that's fantastic. I think that makes a lot of sense. We prototype in MATLAB if that's what you're comfortable with, and then translate. We may not have to write anything in C++ directly if we can leverage OpenCV enough. I mean, a lot of course the most important code paths in OpenCV are likely written in C++ or something else already. So we should be able to leverage that for sure.
Another thing I'll add on that, I rewrote a lot of those original functions that were in MATLAB. I rewrote them in MATLAB in a more MATLAB-like way. A lot of them had been written in C, and I think the performance really wasn't all that far off from as good as you could get. So I'm not too worried about performance at this point because the originals just they weren't nearly as good as they could have been. So.
Cool.
I think performance is still a concern on the computer vision end, though, because the new algorithm KZ is trying is much more computationally intensive than a simple threshold. So we might find that even optimizing that in MATLAB is not enough.
Yeah, fair enough.
The other thing to point out actually is that KZ's algorithm is working already. So we're really talking more about accuracy at this point. And trying to improve it, but he does have a working algorithm. It tracks the worms. It tracks worms through coils, and it does basically work. But we think it can still be a bit better before we think about optimizing for speed.
Great. Okay, so why don't we move on here? I mean, this is kind of a loose structure because we've sort of been talking about a lot of things already, but as I've written in the agenda here, maybe I can speak to something that I've been working on specifically myself. So one focus for me has been trying to rationalize, as I call it, or deal with these little bits of metadata that are attached to these Schaefer files, and try to reverse engineer them, understand where they're coming from, and then understand what we actually need to calculate features. Basically, the Schaefer Lab code had something called segmentation status, and also frame codes, and both of these things are values. Frame by frame values associated with states of the computer vision algorithm. And what I sort of found was that segmentation status was a 4-letter scheme, whether it's success or stage movement or frame dropped or segmentation failed. And then frame codes is a couple more states than that. There's, I think, 10 or so states, 10 or 15 states, which giving more delineations for the failure modes. So there's different ways that the segmentation could fail, and the frame codes have various codes for that. And so I found that segmentation status was basically a subset of frame codes. So I made segmentation status just a property of the video info class. So it no longer needs to be stored separately. It can just be calculated dynamically if needed. And I'm sort of trying to deprecate that piece of metadata. So instead, just using frame codes. And so what I've noted is that in the feature calculation code, frame codes is needed for locomotion turns and posture coils. And this is because, I guess, in the original Schaefer code, these locomotion turns were detected based on the number of frames that were dropped for what the computer vision algorithm determined to be the reason that it thinks that the worm is coiling. Now, of course, if KZ's algorithm can detect these directly and is able to segment the worm through these coils, then obviously we can be rewriting the feature calculation code for this. So I guess then my question would be, guys, do you see any reason to use these frame codes in your code? Do we even need stage movement, for example, in your code? I guess we still need this stuff for the if we're going to continue to have the old Schaefer corpus that we have in that hard drive that Stephen has, and we're going to want to continue to use that information. But for the new videos that we're going to be that you guys are going to be videotaping over there in London, we're not going to need, I suppose, these frame codes. I think that was our go ahead.
Stage motion, exactly as you say. The new videos, we won't have stage motion. I also think it's a good idea to not worry about the coiling as defined by that frame code. That's actually, so in fact, not only is KZ going to hopefully solve that, but in fact, I think the way Avellino is doing it right now, he's not using that portion of the segworm code anyway. So we've on our end, we've sort of already decided that coiling is something we're not going to worry about.
So coiling, you're not going to worry about it in the sense that you're not going to worry about calculating that feature. Is that what you mean?
From segworm.
Using the segworm, yeah.
So I think Avellino's cut out quite a lot of the heuristic parts of segworm that were difficult to deal with, and I think a lot of that is meant to deal with possible coiling cases.
Okay.
So right now we're not calculating that. Once we have KZ's algorithm implemented, we'll put it back in. So
as I sort of see it, I guess movement validation is in the position of having to support this existing corpus of videos as well as the new way. So I guess we'll have to find out some way of having two algorithms for turns and coils, one for the new and one for the old, I suppose. Is that fair enough to say? Would you guys agree with that?
Yes, possibly.
Okay.
So with some of the things I'm working on, I think that'll be relatively straightforward. With getting these refactoring the features and basically iterating over them, we'll just throw a simple switch in there to, if it's this way, then do it one way, and if it's a different video, do it another way. The other aspect of that is we had talked about once we actually get access, or maybe Stephen will talk about this a little bit later with video distribution. We had talked about reprocessing these things, so we could potentially just get rid of the old way once that's set up.
Cool. And then I had one more question about video metadata. So this is, I guess, for Andre, because you have experience with the old way as well as obviously you're going to know what you guys are intending to do in the future. So ventral mode, so calculating or recording what orientation the worm is, whether it's whether it's vulvas on one side or on the other. I believe the protocol in the old method was that I think after or before, I think both after and before recording the 15-minute videos, the operator would use a microscope to see which side the vulva was, and if it stayed on the same side both times, then it was recorded as on one side, and if it was on the other, then it would record on the other, and if it switched, then it would be recorded as unknown or zero. Was the ventral mode for that, and so I guess my question for Andre is, number one, is that correct? Number two, where was that information recorded? Is it just in the file name, or is it elsewhere? And number 3, what's the protocol now in the future?
Okay, so number 1, it was only recorded once manually before putting the worm on the plate. So it's only recorded once. The unknown files are those where it was not annotated. So that's just where we don't know what it was because the operator didn't annotate. The annotation is indeed only in the file name. It's nowhere else. So cases where that file name is confused for some reason, not annotated properly, that will explain some of those unknown examples. Yes. So that's it for the previous. For the future, because we have many worms on a plate, it's not possible to do it in advance because there's no way really of labeling. You know, you could look through the microscope, but there's no way of associating your labels with something in the video afterwards when we have multiple worms. What we're trying to do, what Avelino is working on, is getting the worm side automatically from video. That looks like it has a reasonable chance of working, but we're definitely not there yet. That's harder than head determination.
Okay, fair enough. Now that if the value is unknown, if we don't know the ventral mode, then my analysis of the feature calculation code indicates that we would, like, ventral mode is used to sign several of the features: locomotion velocity, the amplitude and frequency of foraging.bends, and path.curvature. So basically the consequence of not having a ventral mode known is that these are, I guess the sign is unspecified or maybe defaults to positive or something, so that slightly damages our feature data at the end of the day for those features. Okay, so I'll leave that. So that's basically my analysis there, and I've been sort of working on encapsulating all this metadata into the video info class, so that everything's in one place. So that's kind of been my work there. So why don't we? Sorry, Jim, I've taken up a bunch of time. Why don't you go ahead and talk about testing and what you've been working on?
Yeah. So 2 things. One, after much frustration, I think we finally have Travis CI working with OpenCV. Sadly, there's some errors now in the Python code that need to be fixed. Mainly, I think there was some refactoring that was done that wasn't carried over to the testing cases. But importantly, the majority of the Travis CI code is now working, so we can start writing tests, and we should be good to go on that. And then the other thing that I've started working on is trying to make it easier to just iterate over the list of features rather than the structure that I had before. So the idea would be that each feature would be added in and the dependencies would be specified, and then you'd say just say go code and it would calculate all of them. And my hope with that is that we'll improve a little bit on some of the inheritance of these features, such that exporting them to a table or saving them to disk and everything will be a little bit easier as well.
Yeah, just I wanted to ask about the Travis CI. Was that?
Yeah. Go ahead.
We don't know what it is.
Oh, what is it? Oh, sorry. I thought there was a second question. Yeah. So sorry about that. It's a service where every time you push or do a pull request, code will run on a server, and it'll run whatever you tell it to run, and we'll check to see whether or not there are errors associated with the code or not. The difficult thing, so basically you start with a Linux box fresh. It's actually a virtual machine, and you start off by saying download Python, download OpenCV, build OpenCV, download these files. Okay, now run this Python script, which is a test, and do all the tests pass or not. So it's a nice way of, as we're getting new code and people are adding things, they can always run the tests on their own. They can always run the particular Python script, but if they don't, we can visually look at it and say, oh, that's great, but that breaks this, and this in our code. Please fix that, and then we'll merge it in after those problems have been fixed.
Yeah, and if I can say something here, so the purpose of this, which Jim said, but I just want to highlight, is you know, as a code base changes and multiple people are checking multiple things in, this is a way that you guarantee that things work, so that when somebody goes and downloads the code and they try something, there's a guarantee that it works, because if it doesn't work, this Travis CI service will send an email saying things are broken, right? Like the last commit that went in, like somebody broke, you know, this method, and because it ran against a test and it failed. Whereas, like, you know, we don't want to keep running this stuff ourselves over and over again. It's just a machine that just runs it again and again and again and again, as if somebody is starting from scratch. So it provides a level of stability and raises the level of code quality and ensures that it's there every time, every change that gets made. So it's a really good practice. It means that nobody can accidentally break some code and nobody knows about it. It means that there's a continual testing process. So that's why it's a good thing, you know, for code to be in that environment. It's not broken, kind of thing.
Yeah, so that's it on my end. The other thing, is, just to round that off again, the code is currently broken because of some refactoring that was done between Michael and I. But the basics of the Travis CI are there. It's just we need to fix the test. So if you see that it's failed, that's why, and it should be a quick fix that hopefully I'll get to tonight. But that's it on my end. Yeah.
Hey Jim, I don't know if it's worth speaking more about this refactoring of features, because sure. maybe the Brown guys have some questions or issues or support about this. Yeah, I don't know if you want to talk about that some more, because I guess it's a big move on the feature end, I suppose.
Yeah, I mean, I really don't have too much else to say about that. It's just,
yeah, fair enough.
The main, so it started off with we still have a few errors in comparison to the original MRC code. A few of the features aren't matching up exactly. A while back, I thought they had been exact, with the exception of one where I had made a correction and just hadn't bothered to put in some hacks that basically say, if we're trying to match the old code, then do this, this, and this slightly differently so that it exactly matches the old code. At some point that derailed slightly, and there's some differences that have been introduced. I'm not sure why those are, and the thought was that I wanted to make it really easy to say, I only want these particular features. And the current approach would require a lot of going in and hacking around with different things and building support, whereas the new approach is basically going to say, I want to run these features, run them. This is the list of features to run, go do it. And it'll do it, and the dependencies will automatically be handled and whatnot. So I wanted to get that in place before, so that I could then go in and say, okay, now run these particular features. Let's see if I can find out why they're broken or not.
I noticed that that sort of approach also simplifies the calculation of histograms, because the features sort of know what feature type they are, so whether they're an event feature or whether they're a movement or symbol feature, if you know what those things are, it knows what those are, and then it can calculate the appropriate histograms based on that information. So it sort of moves some of that, the feature-related code about histograms into the features themselves, which I think is more consistent with an object-oriented approach, because you can ask of a feature to calculate its histogram rather than have some histogram manager class calculate the feature's histograms. It requires that the histogram manager, our current approach requires that the histogram manager know something about the features to calculate histograms, which kind of breaks the object-oriented model. So guys, I don't know if you guys have an issue with that, any questions about that, or is that okay that we're doing that? Because it's kind of a big refactoring.
Yeah, no, I actually like it a lot, because it's a bit, it gets a bit messy how it is now. But just a couple of questions. Like, what's the difference between simple and event? And second, like in event, there are like a lot of features who are like just a single float that, I mean, they are like frequency or number of blah. But I mean, they seem to me that they should be kind of, at least see when one calculate the histogram, it will be having separate, because just that number by itself is a feature. I mean, one doesn't need to do anything else. So, I mean, they cannot really go out through the histogram.
Well, I suppose because you're grouping like 10 worm videos together, you can create a histogram from even a simple feature. Is that right, Jim?
Yeah. So a lot of this is, I mean, it's at this point it's just literal carryovers from the old code, and a lot of the features that are calculated on a per frame basis, but in the old code, particularly with the events, the event numbers were things like how long did a particular event last, and in some cases it is just a single scalar as to how often were you in the event versus not in the event. What was the ratio between those two? We are very open to suggestions on. I agree it's confusing, and if you think things should be handled differently, I'd love to hear about it, because we really haven't spent too much time trying to think about how to do that differently. It literally is just a translation of the old code at this point. So if things are confusing, let us know, and especially if you have ideas as to ways of making it better, I'd love to hear it.
So as I understand it, the old terminology was, a simple feature was one scalar value associated with the whole video. A movement feature was one scalar value associated with each frame of a video, and then an event feature is a Boolean value associated with each frame of the video. If I'm right about that, so that
slightly. The events are just they're summaries of things that happened only during parts of the video and not during other parts.
Fair enough.
But within that, there were scalars, and then there were arrays of like one value per event. The simple one is actually just it's some weird holdover where when you go from high numbers, or where you go from the base set of features to a high number of features, rather than, I believe, and this is again from not having looked at this in a while, rather than expanding it like 16 times, you maybe only expanded it 4 times, and that 16 expansion was like, what is this feature doing when it's positive, when the movement is positive, when it's negative, when the movement is positive, like all those combinations. And the simple feature just didn't do that, but it was still a frame-by-frame value in that case. Whereas where the scalars were coming from the events.
Then I definitely will prefer, I will propose that the thing is like, from a data point of view, like motion features, all of them has, I mean, they have, it's a matrix of the same amount of times, right? Then simple, and some of the events are kind of like, they have a variable length. And then in event, there are some that are scalars. I think like the best way will be like to group simple with, I mean, like all the ones with variable scalars together, because they kind of make sense from a data structure, and then extract the ones that are floats or like a single number, because like that we can, I mean, with those ones we can just take them and extract them. Like my idea is to recreate these 700 features that were used in the Nature Communication paper, and it's a very nice way to compare between worms. And I mean, in order to do that, you pretty much get the mean of everything except of the ones that are float, like they're just a single number, because already it's a single number, so you can use it. So
yeah, that sounds good. Let's I need to run, but when I get to after the features have been refactored, what you're talking about I think is going to be relatively straightforward. And at that point, let's sit down and talk and make sure that we're doing exactly that we're doing this the way that we should be doing it. Yeah. Does that sound good, guys?
Yep.
Okay. Great. Sorry, I got to run. Talk to everybody later. Good seeing you.
Before you run?
Oh, yeah. Yeah.
Just 10-second comment.
Sure.
In general about the features, I think it's really good to reproduce what's in the paper, but I certainly don't see those as canonical. You know, I think those features can be changed. There's not you know, when we were putting all of that together, there were a lot of discussions of should we put that in, should we not? Let's put it in. You know, so they're not. They can change. There are good reasons to change them in many cases.
Yeah. I think the only concern at that point is well taken. I think the only concern we had was if someone was concerned about, well, we want it that way. Does your code do that? And the thought was that if it's not too much effort, that we can have a little bit of thing in there that says make it that way. Yeah, sure enough, it's the same. But point taken. Okay, great talking to everybody. See you later.
Thanks, Jim.
Bye.
So, FYI for everyone, this is all discussed in issue 133. So if anyone wants to add more or get more background information on this, issue 133. Okay, so with Jim's update done, why don't we move on? Yeah, I guess again we've already sort of had a freewheeling discussion here, but maybe it's reasonable to Kezi and Avelino, do you want to give some individual updates on what you guys have done in the last month or so?
This week I continuously working on my tracking algorithm, and I updated several components. Like I can deal with some corrupted frames in the middle of the video. So even we lost some frames in the middle, I will keep the skeleton, recognize the skeleton stable. Then once we find the good video coming in again, we'll run our algorithm again to catch up the latest video. So that's one thing. And we're also trying to improve our accuracy of the skeleton. And I tune a lot of parameters in my algorithm and try to make it better. And this week I also build a connection with Avelino's work. So basically, Avelino will provide me a lot of data. Now he provides me like the HD5 file, and it consists of many matrix represents each frame, and CM matrix represent the central position of the view. So basically, based on these two data, I can connect my algorithm to Avelino's work very well. And now I can use Avelino's results directly and build my algorithm on this and run. It works well now.
Great.
And one related point actually that's nice about that is that now that KZ is dealing with frame plus center of mass coordinate, that's just the format of the single worm data. So if we, I think the plan is to rerun the single worm database with the new algorithm, and he's prepared to accept that format now of stage position plus frame.
Stage position plus. Okay, I see. So you can deal with stage movements. That's the idea?
Well, not with the motion themselves, but the algorithm is on a motion model. So if the worm is always doing this in the frame, that will confuse.
The view will move according to the position of the worm. So make sure that the worm is in the center of this view.
Beautiful. So you're mentioning skeleton there. Now, Jim did do some work on this in the pre-features that we were talking about. So I don't know if it's worth comparing. I think that we had a little conversation with Avelino about this also. So there's wormparser.compute widths, and I just added I wrote that into your update there in the agenda. That method goes from a skeleton of variable number of points, or sorry, a contour of variable number of points to a skeleton of a variable number of points, and also calculates the widths along the body there. So I don't know if maybe we'll be throwing out that algorithm, or if it's worth comparing them. That's some work there to look at, perhaps.
Okay, like you have the worm parser, right? Like,
Yeah, it's yeah.
I mean, if you have like a small code that shows how it works, I can compare it with with the SegWorm. That is pretty much what I have.
Sure. Yeah, I just there's a link there and a link in the agenda. So yeah, feel free to check it out. The reason why we need it downstream here a little bit is because when we're expecting to accept from the Geppetto team, from the OpenWorm team, just a contour of the worm. We're not expecting the Geppetto team to send us and calculate a skeleton, like the midline. Instead, we're expecting to just receive a contour and then have to calculate that ourselves. So we're going to need that piece of code there to be able to do the processing and have a comparison. So it would be nice to not have to have two different algorithms for that, to have the same one, so we're not potentially introducing discrepancies just because of a different midline calculation algorithm. So anyway, well, we can take that away. Sorry to interrupt. So yeah, Avelino or Andre, do you have any updates you want to talk about?
Yeah, I also tested more videos to see what's the performance. Some of them are like calling worms, and it works well. And even sometimes there are a lot of eggs near the worm's body. It still can work well.
Cool.
Yeah.
Yeah, I mean, for my part, pretty much what I have been doing is, well, I mean, I pass pretty much all my code to Python, like including the part of SegWorm. I have a way to identify where is the head just by the movement of it, which is if the segment is large enough. I mean, if I can follow the worm for enough time, I don't have. It's very clear where is the head. I start to work a bit with the textures, with this thing of knowing where's the ventral side and a little bit where's the head. And I link skeletons in the format I have through the OpenWorm format that I guess is going to be changed for Radical, right, with the features. But for the moment, for what it is existing, I using the movement validation to calculate features and extract something from it directly.
I guess one, not exactly an update for me, but something that Jim mentioned was rerunning the single worm data. That's something I've also been thinking about, and I'd be very excited to do. And I think we could actually, so Nature Methods has a letter to the editor section, which is specifically designed for updates on previous papers. So my hope was to basically rerun those, show improved computer vision algorithm. So whereas before we were missing so many frames because of quills and whatever, now we're missing fewer. Head-tail detection accuracy is better. We've refactored the features. They're now calculated in this way. Improved database, etc. Whatever improvements we can make on the single worm data, I think it would be very worthwhile, and I suspect Nature Methods would be interested in having publishing such a letter. And if you guys wanted to be involved in that, I think that would be excellent.
Yeah, that would be great.
Tie things together and then publish it.
I bet that connects to. Sorry, Joe, I'm bumping you up here because I think that connects to some of what Joe's working on with the cloud work. Because as we sort of envision it, I think if we're all on the same page about this, we'd have our algorithm chained up there, and it would be run on the cloud on our videos there. So we could potentially, have it be running there on Joe's setup. So I don't know, Joe, do you want to talk about what you've been doing?
Sure. I've just been working on the cloud side of things, trying to get a database and a REST framework, API type framework that we can kind of work under and our scripts can interact with, basically. So a central repository to store data and eventually have even automated scripts in the back end that when you, say, upload a video, it does the calculations using the scripts that we have. I guess my next move for things is getting this validated features script running and then just kind of piecing in the other parts of the chain, basically.
Great. Is there anything you need from us on this, or maybe we can take that offline and talk about it some more?
No, I think. Well, okay. So one question I do have: have we decided on AWS versus OpenShift?
I think we were okay with your suggestion there, given that they have free hosting, for example.
Okay.
Do you think it's still a good approach to try OpenShift?
Yeah, I think so. One of the things I did see when I was talking with the channel worm team is OpenShift has grants for research projects and open source projects.
Cool.
Let me see. So that way, one of the downsides of the free version that we're using is that the service will spool down after about 24 hours of inactivity. Spooling it back up is as simple as accessing it with the web page, so it's not a huge deal. So once you go to the web page, it spools right back up. No big problems. But that is one of the drawbacks of doing the free version.
Okay.
But I added the link for the resource grants, and we could probably get some sort of grants, probably for the whole OpenWarm project, to be honest. That would give us dedicated, all the time stuff.
Awesome. Well, let's talk about that offline and make that happen if possible.
Cool.
Cool. Okay, so next here we have Dave. Now I don't know, Dave, if you have any questions. I know you're sort of newer to this whole thing. If you've done any major work in the last month, or any kind of progress that you want to update us on, or if you have any questions about what things would be best for you to work on next, we're happy to talk about that.
I haven't really done anything much in the past month as far as this project's concerned. I'm kind of waiting for issue 133 to get sorted out, so that we get some of that feature stuff sorted out before I write something, and then having to go back and rewrite it, new feature stuff. So.
That's fair. Yeah. There's certainly, as Jim was updating with Travis CI, there's certainly a lot of scope for adding tests. Right now, our coverage is very low, and also documentation could always be improved. We haven't even made the move from RST to Markdown, for example. So that's a potential thing to be done. So there's a few low-hanging issues, if you will, that you could take a look at if you're interested, and anyone else watching. So yeah, that's a fair point, though. Probably doesn't make sense to work on issues until the refactoring is done.
I got a quick question about documentation. I've been on a roll with Sphinx documentation lately on some of my other projects, and do we have a set way of doing that? Can I just start adding to it? Do we have a set way of how we want it to look?
I think the PyOpenWorm documentation is probably the best place to look. They're kind of our big brother, our role model. So
okay.
So check those guys out.
When I start rolling on that one, I'll reference that.
Great. Yeah, and there's a few issues. I think there's at least one or two issues in the repo right now about documentation about Sphinx. So feel free to add your comments there if you're making some progress there.
Okay.
And last but not least, Stephen.
Okay, so a few things relevant, and I mentioned this in general, but it's also potentially something for this group to look at as well, and if you're not familiar with it. So a library called PyOpenWorm, which Michael just mentioned, actually got a new release this week, like 2 days ago, and it's moved a lot of features that have been waiting in the wings to come out into a usable form. And one of those things, one of those major features. So what is it, first of all? So PyOpenWorm, it's a simple API to access data about the C. elegans, and our first focus has been anatomy. So you should be able to do simple things in Python like look up, you know, how many cells does the hermaphrodite have, and what are their names, and you know, what are neurotransmitters that are known to be associated with certain nerve cells, and basically the things that you look up there are the foundations for the models that we build. And so then one of the extra features that we've added, which is often missing from systems like this, is the ability to attach evidence to a given statement. So when you say something like, you know, AVAL is known to have like glutamate as its neurotransmitter, there's the ability to attach an evidence statement there as to, well, who says so, and what paper is that, and to link it actually out to a DOI and that kind of thing. So that is there. This has been a long time in coming as an alternative to just storing a lot of metadata in spreadsheets, which we have in the project, and we haven't deprecated them yet. But the spreadsheet model kind of doesn't scale after a certain point because you're making statements about the same things, like the same neurons, in like 50 different spreadsheets, and then there's no way for that stuff to kind of reconcile itself. It's also been an effort to put out a model in terms of process because it heavily uses things like Travis CI, so unit tests, so there's checks both at the level to make sure that the examples actually work. There's tests to make sure that the data is sane. So if somebody were to go in and like delete a neuron, actually this would raise an error right now. So it has to be, you know, 302 neurons in the hermaphrodite. So that's pretty cool. And there is also documentation on how to extend it, so how to add in other kinds of information. And this is not, you know, does not have to be anytime soon, but something to think about in terms of database, you know, database work. I know you guys have, you know, got databases and you're probably happy with them, and it probably doesn't make sense just to mash these things together willy-nilly. But as we go forward and thinking about having a unified way to build a pipeline from data into a model, it might be worth your time to take another look back at PyOpenWorm. The last thing that we are putting into place probably today is the ability to do pip install PyOpenWorm and have it bring up this latest version. Right now it's still the original alpha, but we have put out a release, a GitHub release that's on there. So anyway, so that's some relevant news as sort of a data underpinning, I think, for the whole project. Check it out, break it, file bugs, that kind of thing. Okay, more relevant to this project directly. So two things. One that's fairly old, since the last hackathon. That really not much has changed, but issue 1 on biological data in GitHub, which I will post here, made a step forward, but again, it's like about 25 days old. So yeah. So the last thing that happened there was during the hackathon time, which is very useful to get to focus. This sort of project of getting this data online really takes like 4-hour uninterrupted blocks, and I tend to try to do PyOpenWorm stuff, or I tend to try to do OpenWorm stuff at more like hour blocks, so this is generally the impedance mismatch. But so let me actually just show you, because I've been working on this here since this has been going. So this is the television in my apartment, and here's the NAS, okay, and right now it's working away, okay, and so this little triangle that's being formed here. So what is that doing? I've been in answer to Michael's request to please can we just see some data, which I respect. I've used the method of Dropbox uploading, which I figured out at the hackathon. So I'm uploading. And I've updated the issue 132 with this content. So there's basically 2 directories that I've uploaded. The first one is already done uploading, and it only has .mat files in it, but you can take a look. This one, which is just uploading right now, has AVIs in it, but they're not yet up. for some reason there's a .data file, a .data folder, and it's got like a ton of mat files called like block 1, block 2, block 3, norm block 1, norm block 2, norm block 3, .mat. Andre probably knows what these are. Anyway, once it's done uploading all those, and it's going to get to the AVIs. This is about I think it's like a 1.3 gigabyte directory. So we'll have AVIs for you, Michael, and it will be there.
Great.
But I can't.
Sorry,
yeah.
Go ahead, Stephen.
Well, I jumped ahead past the hackathon stuff. So the ultimate goal of this stuff is right to get this up as a torrent. And the thing that I had done at the hackathon is that I had fought a lot of battles to get it so that I can actually generate a torrent file. I generated a torrent file and a trivial file. I managed to get that torrent file off the box, which was actually turned out to be really tricky, surprisingly, because even though it looks like I'm running Ubuntu on here, it's sort of crippled in what it's capable of doing on this particular box. So I got it off, and but I have to solve. I still have a problem to solve of an external IP connecting from the outside public internet into this box, and I think that means I have to go into my router and set some proxy settings, and so anyway, it's a bit of a project. But insofar as this thing is up, I'm pulling data off of it. The data is going into is getting uploaded into these Dropbox directories right now. Hopefully, that should at least get you productive, like in this short term, and then yeah, I still have it on my list to get the torrent thing, the final solution, like actually working. But it's looking promising that at least, you know, we've cleared a lot of roadblocks that have been in the way up until then. So yeah.
Well, thank you so much for all your work there, Stephen. It sounds like it's been quite the effort. I have just a question for Andre. So you mentioned writing that letter to Nature Methods based on a rerun of the Schaefer videos. So are you thinking that the way we would proceed with that would be off of the work that Stephen's done here? So, or do you guys have your own copy of all these videos on your end, and they're somehow more accessible than the ones that Stephen has there?
So we do have a local copy. They are not more accessible. I mean, they're more accessible for us, of course. Yeah, in terms of an update to Nature Methods, I think it would be much more interesting if you guys wanted to get as heavily involved as you would like to get, and incorporate, you know, as much of this new stuff that everyone is working on. I mean, I think that would be exciting, but I'm happy to do it however you guys would like, really.
Great.
So either we will, you know, sort of say, well, with Casey's algorithm, we get the coils that allows us to get better head-tail accuracy, and then we just go from there, or, you know, we incorporate as much as you're willing to incorporate, and, you know, make it a much more exciting paper. Awesome. One other thing that we will add actually as well is that, you know, I don't know if you guys have seen wormwatchlab.org. That's our citizen science project. That's people finding egg-laying events in the same data set. So that's the first round of data, which is not the full data set, but the first round of that data is they're about 80% of the way through. So we actually have quite a lot of egg-laying annotations that we can add on as well, which would also be a nice update, I think, to say, you know, we've improved the features we were already calculating, and oh, here's this other new feature, and it's kind of cute because it's from a citizen science project. So I think there are quite a lot of things that would come together to make this an interesting addition, you know, quite an interesting update on the previous paper.
Nice.
So yeah, and the more you guys want to get involved, the more interesting it will be, of course. And so, you know, I would love maximal input from you guys.
Well, great. Yeah. Well, that's certainly, yeah. We'd be very excited to be driving that data pipeline for sure, and maybe even having it be run on our end, and then of course all the analysis, collaborating on that. So that's fantastic. Yeah. Okay. So Stephen, any more on your update, or is that good for you?
One more thing.
Yeah.
One more thing. The International C. elegans meeting is in Los Angeles next week. I will be there. Are you guys going to be there?
I will be there.
Yay. Okay. I also know Balash from the project.
There's going to be a tracking workshop as well.
Who's that?
There's going to be a tracking workshop.
Awesome. Okay, great.
It would be nice to have your contributions during the discussion, for sure.
Okay, great. What day is it? Just so I have it on my radar.
Oh, sorry, Saturday. I just muted my microphone just as I said that.
Okay, good. Saturday. Awesome. Balash will be there, and then some of the guys on the development side will also be there. And so it could be interesting to try and get folks together. When do you get in, Andre?
Tuesday evening around 7 p.m.
Okay, so you get in for the first, right? Like, there's, I guess the kickoff is that night, right?
Yeah. I'm not sure if it's an event that night or if the kickoff is the next morning.
Wednesday is the kickoff. Yeah. Okay. Okay.
Yeah. So yeah, if you want to, are you going to be around on Tuesday? Said he might be around already on Tuesday.
Yes, I will be in town. Yes, and in fact, at noon on Tuesday, I'm connecting with somebody with Balash at UCLA. I have to check out. So I will be at UCLA at noon. In the evening, I think I'm getting dinner with a friend. But then, but yeah, I can generally be around. So let's send some mails on that.
Mm-hmm. Yeah, great.
Yep, and I'll see if I can hand out some OpenWorm stickers and things and talk to people. So, okay, cool. So that'll be good to connect and catch up on some of the stuff.
Great. Okay. Well, thanks, Stephen. So we are definitely more than at the top of the hour at this point. Does anyone have any last-minute comments? Okay. So we are out of time. That's it for now.
Have a good one, guys.
Pardon me?
Have a good one.
Yeah. So looking forward to more progress in July. So see you all next time. Thanks.
Bye. Thanks.
Thank you. Bye.